All right, today we're going to be doing questions 1 through 7 of the 2021 Mock EOC Study Guide. So a rectangle has side lengths of 2x squared plus 4x minus 3 and negative 4x plus 3. How would you represent the area of the rectangle? Well, if we know that the area is equal to the length times the width, right? That's something we've learned before. I can assign that trinomial, 2x squared plus 4x minus 3, assign that as the length, and that negative 4x plus 3 as my width. So all I have to do is multiply those two polynomials together to find the area of my rectangle. So to do that, I'm going to use the box method. So I'm going to have 2x squared plus 4x minus 3. And that's going to be along the top of my box. And on the side, I'm going to have negative 4x plus 3. It's a little uneven. I can fix that. All right, so now I just need to start multiplying to fill in the box. So 2x squared times negative 4x is a negative 8x cubed. Negative 4x times positive 4x is a negative 16x squared. And negative 4x times a negative 3 is a positive 12x. Positive 3 times a 2x squared, which is also positive, is 6x squared. 3 times 4x is a positive 12x. And a positive 3 times a negative 3 is negative 9. Now, before I start pulling these numbers out of the box, I'm going to look for like terms. So I have a negative 16x squared and a positive 6x squared. And I also have a positive 12x and a positive 12x. So my area is equal to negative 8x cubed. I'm going to combine my positive 6x squared and my negative 16x squared to get a negative 10x squared. I'm going to add the 12x plus the 12x, and so I'll have a positive 24x, and then finally a negative 9. So that is the answer to number 1. Number 2, NCMS is renting a venue for $500. For an upcoming dance. Each student attending will pay $1.50. All other attendees will pay $3 each. If 600 students attend the dance, write an inequality you would use to determine how many other attendees, or X, are needed to cover the cost of the venue. Keyword here is inequality. So we won't have an equal sign, we need to have an inequality sign. So let's pull all these numbers together. The venue costs $500. And we need the number of students and other attendees that are attending to make at least $500. So we're going to have 600, because there's 600 students, multiplied by $1.50. And then we're going to add that $3 times X. And that total needs to be greater than or equal to $500 in order to cover the cost of the venue. Okay, all of those numbers came from the word problem. I wrote my linear function. And now I can move on to question number 3. Solve the following formula for S. So this is a rearranging formula or literal equation, and this came from section 2, topic 8. So if I'm trying to solve for a specific variable, in this case s, I need to get rid of everything else that is currently with that s. So the first thing I want to remove is this y squared. Well, that 2s is being divided by y squared. So to move that y squared to the other side of the equal sign, I need to multiply by y squared. And if I multiply on the left, I'm going to have to multiply on the right. If I multiply by y squared on the left, that denominator goes away. And if I multiply that h by y squared, then I'm going to have 2s is equal to h y squared. But I still don't have that s on its own. I still need to isolate that s. That 2 is being multiplied by the s, so now I need to divide that 2 and divide that 2 on the other side of the equal sign. If I divide by 2 on the left, that's going to become 1. And then I have my divide by 2 on the right. So my final answer is s is equal to hy squared divided by 2. Moving on to number 4. Carla volunteered to make pies for a bake sale. She bought 2 pounds of apples and 6 pounds of peaches and spent $19. After baking the pies, she decided they looked so good she would make more. She went back to the store and bought another pound of apples and 5 more pounds of peaches and spent $15. What is the cost of 1 pound of apples? All right, this is a systems of equations question. They've given us 2 equations here, and we have to use those 2 equations with those 2 variables to solve for 1 variable. So first I have my 2 pounds of apples. So I'm going to write 2a, a meaning apples. And she bought 6 pounds of peaches, so plus 6p. And she spent $19. The second time she bought 1 pound of apples, so just a, plus 5 more pounds of peaches, plus 5p, and she spent $15. We need to determine what the cost of 1 pound of apples is. So if we have a systems of equations, what we need to do is either solve by substitution, you can solve by graphing, or you can solve by elimination. I'm going to use the elimination method. And in order to use the elimination method, I'm going to have to multiply this second equation by 2. When I multiply the second equation by 2, I'm going to get 2a plus 10p, and that's going to equal 30. Now that I've multiplied that second equation by 2, I can subtract this first equation, which was 2a plus 6p equals 19. If I subtract that equation from the other equation, then I will eliminate one of the variables. So 2a minus 2a becomes 0. 10p minus 6p becomes 4p, and that is equal to 11, because 30 minus 19 is 11. Now that I have 4p is equal to 11, If I divide by 4 and divide by 4, I find that P is equal to $2.75. So that's the cost of peaches per pound. Now to find the value of my A, I need to plug in that value of my P, my peaches, which I'm going to highlight here in blue. Now I'm going to plug that value in to this equation to find the value of my A, my pound of apples. So I'm going to have A plus 5 multiplied by 2.75 because I'm replacing that P with the $2.75, and that's going to equal $15. Well, when I multiply 5 times 2.75, I get 13.75. So A plus 13.75 is equal to 15. Then I subtract 13.75 from both sides, and I find that A is equal to $1.25. And that is the cost of my pound of apples. So 1 pound of apples costs $1.25. All right, moving on to number 5. Which systems of inequalities describes the graph? So we all hate graphing inequalities. They're not the most fun thing in the world. So there's a few things we need to look at. First, we have a dotted line. This dotted line means it's going to be either greater than or less than. There's going to be any equal signs. When we have a solid line, then we're going to have greater than or equal to, or less than or equal to. Okay, so I'm looking at this solid line. This solid line has a negative slope. So my M is equal to a negative number. And my B, my y-intercept, is equal to 4. So I know I'm going to have a negative slope and a y-intercept of 4. So let's look at my equations. Okay, negative slope, y-intercept of 4. Here's my y-intercepts of 4. Is there any that I can eliminate? Well, D has a positive slope, so I can eliminate that one. B has a less than symbol instead of a less than or equal to symbol, so I can get rid of that one. So I'm left with A and C. Now let's look at B. Our dotted line. Let's look at our dotted line here. All right, so if our symbol either has to be greater than or less than without the equal sign, let's see if there's any we can eliminate. Okay, we're looking at this second equation now. Any one of those second equations that has a greater than or equal to sign, we can now eliminate. So that gets rid of that one. Okay, A and C are still possible. So let's look at it a little bit further. My y-intercept for that dotted line looks to be about -2. I'm going to label that as my B. So my B here is equal to -2. But what is my M, my slope? My slope here is going to be up 2 and over 2. So my slope is 2. All right, both of those second equations in question 5 are exactly the same. 2x minus 2, 2x minus 2, y is greater than, y is greater than. So we're not going to worry about that dotted line equation any further. Let's look at that first one. All right, we have negative 1/2. Y is less than or equal to negative 1/2 x plus 4, or y is greater than or equal to negative 1/2 x plus 4. Well, what does it mean to be greater than? Well, if my y value is greater than, then that means that my y value is increasing. So if I'm looking at my solid line right here, if I'm looking at this solid line, if it's going to be greater than, it's going to be on that side. It's going to on the top part of that graph, which eliminates C because the key area that's shaded in for both functions is right here in the black. And this is telling me that y is going to be less than or equal to that negative 1/2. So our correct answer here is A. The reason why number C will not work is because that inequality sign, that shaded area, does not meet that criteria. All right, let's move on to number 6. Identify each property that was used to solve the equation. This came from section 2, topic 2. So let's first look at these properties. Step 1, we had 2 times 4x minus 8 minus 4 equals 6. Well, that was given to us. That's not a property. To go from step 1 to step 2, what did they do? Well, they added 4 to both sides, so they used the addition property of equality. From step 2 to step 3, they distributed that 2. So 2 times 4x is 8x. 2 times negative 8x is negative 16, and then that was equal to 10. So they used the distributive property and from step 3 to step 4, they added 8 to both sides, so they used the addition property again. And in step 5, from step 4 to step 5, they had to divide both sides by 8, so they used the division property. Oops. Now the question asks, which property was used incorrectly when going from step 2 to step 3? Well, step 2, they use the addition property. Step 3, they use the distributive property. But look at right here. When we distributed in our notes, we got a negative 16. But in their version, they got a negative 8. So the property that they used incorrectly, the distributive property. They didn't multiply the 2 times the 8.